The HMM with input. In some applications, additional to the observation sequence OT, we have an input sequence XT. We can condition the observation OT in state Sj on the input x to the t and write the probability of OT conditioning on Q t equals to Sj and xt. In the case when the observations are continuous scalars, we replace equation 15.38 with a generalized model. The probability of OT conditioning on Qt equals to Sj, xt, and lambda is approximately by the normal distribution of Gj of xt conditioning on theta j and also sigma j to the square. So we're, for example, assuming a linear model, we have Gj of xt x to the t conditioning on wj. Wj0 is equals to wj times x to the transpose. X to the t, not x to the transpose, plus wj0. If the observations are discrete and a multinomial, we have a classifier taking x to the t as input and generating a 1 of m output, or we can generate posterior class probabilities and keep the observations continuous. Similarly, the state transition probabilities can also be conditioned on the input, namely the probability of qt plus 1 equals to sj conditioning on qt equals to si, and additional input parameter in the conditional probability xt, which is implemented by a classifier choosing the state at time t plus 1 as a function of the state at time t and the input. This is a Markov mixture of experts. It's proposed by Myla and Jordan in 1996 and is a generalization of the mixture of experts architecture, which has been mentioned in section 12.8, where the gating network keeps track of the decision it made in the previous time step. Such an architecture is also called an input-output HMM, which has been proposed by Bengel and Frasconi in 1996 and has the advantage that the model is no longer homogeneous. Different observation and the transition probabilities are used at different time steps. There is still a single model for each state parameterized by theta j, but it generates different transition or observation probabilities depending on the input seen. It is possible that the input is not a single value, but a window around time t making the input a vector. This allows handling applications where the input and observation sequences have different lengths. Even if there is no other explicit input sequence, an HMM with input can be used by generating an input through some pre-specified function of previous observations, that is xt equals to f of ot minus tau and ot minus tau minus 1, and also so on until ot minus 1. We're talking about replaced by capital T also, and thereby providing a window of size tau of contextual input.